Alright, what is up everybody? I'm back again today with another video, and in today's video we're going to cover how to multiply and divide polynomial expressions, and we're going to add restrictions in at the end to see what the variable values cannot equal to. Right, so we're going to do a little tutorial on this today. So these are like some good test questions to use if you're preparing for a unit test or a chapter test, right? So let's start off with this first question right here. We have 6x over 8y times 2y squared over 3x. So if we go back to this multiplying regular fractions, right? Let's just say we have 7 over 8 multiplied by 2 over 3. If we just have multiplying regular fractions, we know that 7 times 2 is equal to 14. And then 8 times 3, 8, 16, 24 is what we get in the denominator, right? So if we multiply fractions, we just multiply the top and then we multiply the bottom, right? So that's one way to do multiplication. But now we're dealing with variables, right? So we have to do the same thing, and we're going to just treat it as if it was a regular fraction problem, right? So we're going to do 6x on the top multiplied. So we're going to use this dot symbol to represent multiplication now. So 6x dot 2y squared on the top divided by 8y dot 3x on the bottom, right? So essentially what we do is we're going to multiply this. So we have 6 times 2, right? So we always multiply the numbers by itself, right? So we have 6 times 2 is equal to 12 on the top. So we have 12 on the top, and then we have to multiply the variables. So we have x times y squared. Now, if we remember anything about exponents and with variables, right? For example, if we have x to the power of 1 multiplied by x to the power of 2, we know our exponent rules are if we're multiplying two variables with exponents, we add the exponent. So this then becomes x to the power of 1 plus 2, which in turn is x to the power of 3. Now, if we're dividing, if we have x to the power of 2 divided by x to the power of 1, we know that when we're dividing variables with exponents, we do subtraction. So it becomes x to the power of 2 minus 1, which essentially becomes just x, right? So those are our exponent rules. So when we multiply variables with exponents, the exponent values add to one another. And when we divide variables with exponents, the exponent values subtract from one another, right? So right here we have the x times y squared. There's x in let me use different colors. So we have an x on this term, but there's no x in the second term, right? So we just know that it's 12x. So you can go ahead and write that in. So it's just x times 1 basically. And there's no y in this term, but there's a y squared in this term. So it's basically y squared times 1 essentially. So we can end up putting y squared on the top, right? So we have 12x times y squared. Now for the bottom part, it's the same thing. We have a y over here, but there's no y over here. And we have an x over here, but there's no x over here. So essentially, we multiply the numbers first. So we get 8 times 3, which is equal to 24. We get 24 on the bottom. And then we get y times x. So it's y times 1 times x times 1, which is essentially just y and x. So we just multiply those together, right? We just put them together, right? So essentially this is what we have so far in our equation. Now, how do we simplify this further? If we have 12xy squared and 24xyx, right? 24yx, I mean, sorry. So what do we do? If we look at our division laws when we have exponents in variables, right? If we look at this section right here, we know that when we divide it, we subtract it. So we know there's a y squared on the top and a y at the bottom and an x on the top and the x at the bottom. So we know our numbers are going to stay the same. So let's go ahead and write down the 12 by 24, right? And then over here, let's look at the x. So here we have x1, and on the bottom we have x1. So essentially it's just x1 divided by x1. So we have to isolate each variable to be by itself. So we have x1 by x1. So we add like terms with the x's. And essentially this is equal to x1 minus 1, right? And then this becomes x to the power of 0. And x to the power of 0, anything to the power of 0, just becomes 1. So x to the power of 0 becomes 1. So if we do 24 right here, we know that because it's 1, these two x's essentially cancel out and they're no longer in the equation, right? So these two x's get canceled out and we no longer need them because it becomes x to the power of 0, which is essentially 1. So if we multiply this whole term by 1, nothing will change. If you look at the y term, we have y squared divided by y. And this essentially becomes y squared minus y, because this is a 1 right here, right? At the bottom there's a 1, and on the top we have a 2 here, right? So essentially this then becomes y to the power of 1, right? So then we have y to the power of 1 on the top, which is left. So the 2 minus 1 results in just a y1 at the top. So in the top we can just put 12y. So then our final answer is essentially 12y divided by 24. And then that would be our final answer for this problem, right? But if we want to simplify this further, we know that 12 divided by 24 is just 1/2. So if we want the very simplified version of this answer, it would then be 1/2 times y, because 12 over 24, if we can do it over here, 12 divided by 24 is equal to 0.5, also known as 1/2. So we can simplify the larger constant numbers to 1/2, and we keep the y there as 1/2 y. All right, so now that we're done this example completely, let's go ahead and start with the next one to get better understanding and more practice to how to multiply polynomials. So here we are again with example number 2. We have 10m squared over 3n multiplied by 6mn divided by 20m squared. So we're going to do the same thing we did before. So we're going to multiply the top part. So we have 10m squared multiplied by 6mn divided by 3n multiplied by 20m squared. So now, as you can see, we have an m squared over here, and we also have an m over here. So if you remember, m squared multiplied by m to the power of 1 essentially is essentially m 2 plus 1, which results in m to the power of 3. So we know that there's going to be m to the power of 3. So if we go ahead and solve this, we know that we always multiply the numbers first. So we have 10 times 6. So 10 times 6 essentially equals to 60, right? And then we have the m cubed, right? So m to the power of 3 solved. So after we have the m to the power of 3 solved, then we have to focus on n. So if we look at n, there's no n over here, but there's an n over here. So you have n to the power of 1 essentially multiplied by 1, which then results in just a 1n over here, right? So it's just n times 1, which is just n. So that's our top portion, right? Now our bottom portion, let's look. We have 3n times 20m squared. So what we do first is always the numbers. So we multiply 20 by 3, which is 60 once again. So we have 60 on the bottom. Now we see that there's an m squared over here, but there's no m over here. So it's just m squared times 1. So we know m squared times 1 is just m squared. So anything times its 1 is itself. So you can put an m squared on the bottom, right? And now we have an n over here. And because we have an n over here and no n over here, it's n times 1 again. So it's the same as what the top was. So it's just n over here. Now, how do we simplify that? We have 60m cubed n divided by 60m squared n. Now, what do we do? Well, we can simplify it again further. So we know that when we divide it, if we look at as in variables, we put in portions, right? Let's divide this into 3 separate sections. We have 60 divided by 60. And with our math skills, we know that 60 divided by 60 is just equal to 1, right? So that will be the first column. Then we have m cubed divided by m squared. Now, when we do this, we know that it's m3 minus m2, which is essentially m to the power of 1. And we know this is because we know how to divide variables with exponents, and exponents subtract each other when they're divided, right? So when they're divisible, we subtract them. So we have n to the power of 1. Then for the last part, we have n over n, right? And this is the same thing as 60 over 60. But if you want to put exponents into it, we can do 1 and 1. So we get n1 minus 1, which is equal to n0, which is essentially anything to the power of 0 is 1. And anything divided by itself is 1 as well, right? So we get 1 just doing it the regular way. So essentially, we get our final answer of this question to just equal to 1m1, right? So these are all multiplied. And essentially, this becomes m. Because anything times it's 1, anything times 1 is just itself. And then that would be the final answer for this question, as it's just m. And because there's no denominator present in the final answer, we do not have to place any restrictions on this specific answer, as there's no denominator, so the denominator can never equal 0. And because there's no variable in the denominator, we do not have to label any specific restrictions. All right, so that's how we multiply polynomials, and let's get into an example of how to divide polynomials now. So here we are with our third example of how to divide polynomials. We have 2ab divided by 5bc, and then and the whole fraction is divided by 6ac over 10b. Now let's remember how to divide fractions real quick. So let's just do our same example again. We have 7 over 8 divided by 2 over 3. Now, the easy way to divide polynomials is to just flip over one of the sides. So for example, if you want to flip over the right side, then this becomes 7 over 8 multiplied by 3 over 2, right? So essentially what we did is we changed the division sign to multiplication, but the 2 over 3 gets flipped as the reciprocal side. So the 2 over 3 becomes 3 over 2, as a quick reminder of how to divide fractions, right? So on the top, we just go back to our simple multiplication rules. So 7 times 3 is 21, and then 8 times 2 is 16, and then that would be the answer, right? So what we have to do is change it to multiplication and flip one of the sides. So if we're going to get started with this question, let's see what we can do. So we're going to have to flip over one of the sides and change the sign to multiplication. So we're going to go ahead and put 2ab divided by 5bc. We're going to change the sign to multiplication, and we're going to change this and put the reciprocal over here. And then essentially this becomes times 10b over 6ac, right? And now there's a question essentially becomes just another multiplication problem, right? So it's just 2ab times 10b and then 5bc over 6ac. So if we go ahead and do that, we know that there's a b here and a b here. So we know b1 plus b1, right? b1 times b1. Actually, sorry, my mistake. So we have b1 multiplied by b1 is just equal to b1 plus 1, which is equal to b over 2, right? Because there's a 1 here and a 1 here. And then that's essentially how we add the exponents, right? There's an a here and no a here, so it's just a times 1, which is just a. So we know that the top value is going to be equal to 2 times 10, which is equal to 20, a, and b squared, as of what we calculated over here. That's our top value. And on the bottom, if we multiply the numbers first, we have 5 and 6. So 5 times 6 is equal to 30. Correct? We have 30. Then, as you can see here, we have a b here and no b here. So we have a b there and a no b there. So we know that's just b times 1. So we just get b, right? B is a 1. Then we know that there's a c here. We know that there's a c here and a c here. So we get c1 times c1, which is c1 plus 1 is equal to c squared. Correct? We get c squared over here. So we know that at the bottom we get c squared as the exponents add to one another. As there's a 1 here and a 1 here. And then finally we know that there's an a here multiplied with that 1 over here for the a. So it's just a by itself. So we can put an a over here on its own. Right? So then that would be our answer. Now we have to simplify this further. So if we have this, we can do the a's. So let's just look at the a variables. So if we look at this a and this a, we essentially get a1 over a1, which is essentially equal to a1 minus 1 equal to a0, which is just equal to 1. So their a's cancel out, right? Because it's just equal to 1. Now if we go further, we look at our b's. So we have b squared and b. We can get b2 over b is equal to b2 minus 1, which is equal to b to the power of 1. So we know that there's a b remaining on the top, and the 2 cancels out with this bottom b, right? So we know there's a b remaining on the top. Now let's look at c. There's no c on the top, and there's a c on the bottom. So essentially we can't do anything, and the c squared just remains on the bottom. So essentially our final answer would then be 20. And then because there's a b1 over here, we keep a b1 that's on the top. So it's 20b over 30 c squared only, because the a and the b on the bottom both got canceled out over here, right? So then all we have is this. Now, this is our final answer, right? So it's 20b over 30c squared. But because there is a variable in the denominator, so this is our numerator, right? The top is the numerator, and the bottom is the denominator. And we have a variable in our denominator, right? So we have c squared in the denominator. Now, one rule that we have is that the denominator, oops, am I spelling it wrong? Denominator can never equal 0, right? So because we have a variable in the denominator, we have to see if there's any number that c can become that would make the denominator equal to 0, right? So 30 multiplied by what number makes the denominator 0? And after doing this, we can realize that when 30 multiplied by 0 squared is equal to 0, we know that c cannot equal to 0. So then we put a little thing at the bottom here. So c cannot equal. So this symbol represents cannot equal, right? So c cannot equal 0. And then that is our restriction, right? That is our restriction, that c is unable to equal 0, right? So that's how we do a division problem with a restriction, as we have a variable in the denominator, right? So remember, when we divide polynomials, we change the sign to multiplication and then flip over one of the sides. So we have c cannot equal to 0 because of restriction, as then 30 times 0 would then result in the denominator equal 0, which can also never happen, which is why we need a restriction. All right. So maybe let's go ahead and do one more example of how to divide. Over here we have our last example. We have 5p divided by 8pq divided by 3p over 12q. And if we remember how to do division, right, we do 5p over 8pq. We change it to a multiplication sign, and we flip this over to the reciprocal. So it's multiplied by 12q over 3p, right? So that's what we get. So then what does that result in? So we have 5p. So we have 1p over here. There's no p over here, so it's just p times 1. We have a q over here and no q over here. So we know it's q times 1. And we always have to multiply the numbers. So 5 times 12, right? And if we figure out what 5 times 12 is equal to, we know that that's equal to 60. So you have 60. P times 1 is just p. Q times 1 is just q. So we have 60pq on the top. Now on the bottom, we're going to multiply the numbers first. 8 times 3 is equal to 24 for the bottom. We have a p over here and a p over here. So we know p1 times p1, because these are both to the power of 1, is equal to p1 plus 1, which is equal to p over p squared, right? So we know this p squared on the bottom. We can go ahead and put that in. And now we know that there's a q here, but there's no q here. So it's just q times 1. So we have q times 1, which is just equal to q. So we know at the bottom it's just 1q, right? So that's how we quickly get our equation. But now we have to simplify it further. So if we put this out into columns really quick, right here. Let's not worry about the actual values for now. So we have 60 over 24 for now, right? Now look at the p value, right? So you got p1, so we have 1 to the power of 1 here, p1 over p2, which is essentially equal to p1 minus 2, which is then equal to p negative 1. Now we have a p to the negative 1, and whenever we have something to the power of negative 1, that means that it is essentially in the denominator. So whenever something's in negative 1, this equals in the denominator, right? And what that means is that there's no p on the top, but it's actually on the bottom of the fraction. So we can go ahead and add the p to the bottom, right? So because it's negative 1, there's a p to the 1 over here. Basically, the negative 1 just means it's on the bottom, right? So it's 24 p to the 1 on the bottom. Now, if we look at the q, we see that there's a q over q. So we have 1 over 1, which is equal to q. 1 minus 1, which is equal to q to the power of 0, which is just equal to 1. So we know that there's no q in the answer, right? So essentially the two q's cancel out. And if we look at the p's, this p cancel out with this 2, so there's only one p left in the bottom. So our final answer essentially is then equal to 60 over 24p. Now, we have a variable in the denominator. Now, because we have a variable in the denominator, what multiplied by 24 results in 0? Because we know that 24 multiplied by 0 is equal to 0. Therefore, p cannot equal to 0, and then that is our restriction. Right? Because the denominator can never equal 0. So what value of p results in 0? We know that 24 times 0 is equal to 0. So therefore, p cannot equal to 0 as our restriction. All right? So that's how you basically multiply and divide polynomial fractions with also adding restrictions in the answer. So I hope if you guys enjoyed and liked this video, please make sure to like, comment, share, and subscribe. If you guys have any more questions or concerns, please comment down below or email at sharranacademy@gmail.com. And if you guys want me to cover any specific questions or topics that you guys have, please comment that down below. I'll make sure to make a video on it as soon as possible. All right, thanks guys. Thanks for watching.